introduce our speaker today, Mike Webster from SolaSense. Mike, can you tell us a little bit about yourself?
Yes, I've been in the oil and gas industry for the better part of, I kind of lose track now, it's about 30 odd years. I had 34 years in BP, ended up as the ridiculous title of Distinguished Advisor in Petrophysics for BP, which made for an exceptionally long business card. I retired about 3 years ago, did not want to hang up my calculator and decided to keep technical, so I've done quite a bit of consultancy work, do a bit of teaching, and a group of like-minded guys, most of whom are retired, formed SolaSense a few years ago with the specific aim of trying to solve some issues in fibre optics.
Thank you. Can you tell us a little bit of what you're going to talk about today, but don't give too much away? Or tell us a little bit more on SolaSense.
SolaSense, what I'm going to talk about today is actually a plea for more surveillance in general. I've worked cased hole for the main part of my career as a petrophysicist. Most folk kind of think of the exploration appraisal stuff as being all the sexy end of the business. I always prefer to work mature fields, clapped out reservoirs, clapped out wells, because those are infinitely more interesting. And so the whole point of the SolaSense piece was around trying to address and generate products for the industry that were simple, easy to use, that you did not need a PhD in optics to get your head around or use to make it accessible to the bulk market.
Thanks, Mike. Sarah, can you tell us why this is of interest to the OGTC, please?
So it's of interest to the OGTC because it touches on a few of the key themes that we have in our Well Solutions Centre to maximise recovery from our wells and to optimise their abandonment. So obviously well surveillance is employed to better recognise leak mechanisms, pressure sources and complex flow pathways that might compromise the integrity of our wells. So that really is one of our main interests in maximising production for the North Sea and optimising our abandonment, reducing our abandonment costs. So without further ado, Mike, are you ready?
I'm always ready.
Okay, your 20 minutes starts now.
Okay, SolaSense, that's the splash screen, so we'll skip over that one. I was on the steering committee and board for the SPE Surveillance Conference that happened in October of this year. And the opening address by Glenn Brown from the Oil and Gas Authority was actually quite depressing because he came out with some numbers that said, well, you know, really only about 2% of the well stock have active surveillance in the programme in any 1 year, and it's been going down. I think the previous surveillance conference, it was about between 6 and 8%. That was 2 years ago. So we are seeing a decline in surveillance. We know that production is declining about 5% per annum. 30% of the supposedly active well stock is shut in. And so well losses are increasing. So there's a huge potential prize there if we can get surveillance that addresses well issues that operators can grab hold of and run with. I asked the specific question of Glenn at that event. What would he expect surveillance to be running at? And when pressed, he came out with 20%. So there's a huge gap between what's actually happening out there and what the expectation of the people in the Oil and Gas Authority are. Historically, we tend to be reactive. Operators wait for something to break before they end up doing something about it. You suffer the production losses because wells fail on their time, not on your time. And you scramble around for the facilities, crews, and equipment to gather information to perform remedial action. So we're always caught on the back foot, so we're in survival mode. What we need to do is to get more proactive about this whole business. So, I remember way back when I first started in BP, I used to work on Forty's platform, and again, that was all cased hole work. We used to go out there and log baseline surveys in wells because we knew that at some point in the future, if I've got a baseline, it makes it a heck of a lot easier to diagnose what's wrong with the well. Very, very seldom have I ever seen baseline logs in the well stock these days. And that's a really sad thing. So what we want to do is we want to be more proactive about things. We want to generate opportunities by gathering this information and predicting when things will become a problem. Wells are predictable. If you look at any Prosper analysis or nodal analysis on a well, if you know the reservoir pressure is going down by a certain amount per month or year, or that the water cut is increasing by X%, you can predict when that well is going to fall over. So the time to gather information in the well is before it breaks, because an unstable well will give you unreliable information. It's not a healthy place to be. So what we want to do is to be more proactive in getting the surveillance so that we can really thrive, use that to our advantage. Sensors come in many guises. All sensors have strengths and weaknesses. If we think about satellites, for instance, they've got a whole array of stuff that they can cram on there that they will utilize. And so relying on any one measurement is not a secure place to be. We need multiple ways of getting at bits of information that we pool together in some coherent way to try and solve what we're trying to solve for. So one thing is not a robust there's no silver bullet. You have to look at an array of measurements to try and solve the problems at hand. And certainly satellites are of that vein. We tend to be really siloed in our, so the wells guys, they gather this piece of information, reservoir engineer, oh yeah, pressure temperature, that's theirs. And we don't look at things holistically. And that's a bit of a missing. Automation, there's a drive in the industry for, we want fewer people, we want to shove all the data into a black box, hit the go button, and it'll tell us the answer. But what that ends up doing is it's only on what you've trained it to look for. Wells tend to be individual things. Open hole log analysis that I'm really familiar with, I can take a suite of measurements, build a model for that field, hit the go button, and I know I'll get a reliable answer. Cased hole is very different. Each well is individual, and it's a much more difficult thing to try and work out what's going on. And so it makes the whole artificial intelligence and the neural net stuff more difficult to contend with. And so what we've tried to do in SolaSense is to say, well, we want to maximize the volume of data coming in, but leave it to the individual and their experience to work out what's going on. If you are the operator of a field or a well, you've had years and years of experience knowing what goes on in those wells, what causes the well to break, what causes the well to fail. If you're a service provider coming in, you know your sensors, but you don't know the field, you don't have the background. There has to be a marrying together of those skill sets to give you a robust solution. And we've got to think about the life cycle of a field and the life cycle and needs for the well and the reservoir. Kids, everybody, there's a lot of folk in the room who know these are a lot of hard work, and their needs are really different to the needs of aging parents. And I've been at both ends of that spectrum, and so you know that what is required for a new system is quite different to a mature system. And so think about the life cycle of the well or the field. What information do I need to acquire early on that will help at this end of the spectrum? So what we've done is we've tried to create this cheap, simple, easy-to-use system. The whole philosophy is, if I cannot teach you how to use the software or the hardware in an hour or two, then it's too difficult. I can't guarantee that the person going offshore will be fully trained up in the software or the hardware. It has to be easy enough for them to do that with a minimum of training. And as soon as we get to that place, then all of a sudden I can take a standard wireline, slickline crew, whatever you want to use, go out there with this technology and run it reliably. So what we want to do is we want to be flexible with companies as much as possible. We have been working with the likes of Paradigm, who have, this is their slickline-enabled fiber, and WellSense, who've got the Fly system, the fiber optic dart that deploys bare fiber. So both of these things are available on the market now, but what both of these companies struggle with is the ease of use of the surface acquisition units, because those are quite expensive and quite delicate instruments, quite complicated to use, and then the processing and interpretation of the product afterwards. And so while the deployment is being handled by other companies in the market, the units and the interpretation are not. So what we've ended up with was almost every single system on the broadband BT OpenReach VAN in the country will have an OTDR in it for checking the health of fiber. That OTDR unit, we've worked with one of the main suppliers of OTDR to generate something that's fit for oil field purposes around the interrogation box. And these guys are producing thousands of these per month. So we get the economies of scale and the robustness of a workaday artisan unit that's small, self-contained, portable, and really easy to use, and has been field tested for decades by broadband suppliers, telecoms people. So these are not hand-built one-off units. So the key features: low cost, rugged, portable, simple to use. And that is the beast itself. The display software, what we needed to do was to pull all the elements of information in one place that we need to make a decision. Almost always, there will be a sensors package at the bottom of the fiber that will contain pressure, temperature, gamma, CCL, an array of traditional type measurements. So we have to accommodate that. And so in this display, we've got gamma CCL, memory, gauge, pressure, temperature. So it's a plain Jane, let's see the data thing. We also need all the static information we got in the well, the casings, the formation tops, completion components. Those are all provided too in the display. And alongside that, there is the Fourier transform extraction from the acoustic distributed data. And this is one image of a large number of images over the whole data set. Because what we found was, I cannot readily predict the settings that are appropriate for any one circumstance, even in the same well. So in this case, we've got a 0 to 5 hertz display and a 0-1 spatial and temporal setting. If I change those settings or change the frequency bands, this image changes. And so I can see features come and go over the, as those settings are altered. And so what I want to do is to allow the user access to all of those. So you can cycle through these images and tease out the features that you want to extract and then make your interpretation. And then likewise with the temperature data, I need to do the same sort of process. So there's multiple ways of processing and displaying that temperature data, but it's most powerful if it's all displayed on the same page at the same time. So I've got the temperature, the acoustics, all of the memory data, and my static information I know about the well. And all of a sudden, it becomes really clear what's going on in the well. And in this case, we actually, there's no laser on that, is there? Oh, well. In this case, it was really clear that there is a leak at the side pocket mandrel towards the bottom there, and that we had a fluid increase in the annular space between the tubing and the casing. And that's what was causing these features. And that information also tied in with the change in fluid gradients seen on the way in and on the way out of the well on the tubing side, and the change in pressure in the annulus side. So it's a really good way of absolutely nailing the diagnostics on that example. Gas lift valve was changed out, was found to be faulty, fixed the problem, well returned back to production. 6 minutes. So what we've got is, we do have 600 shut-in wells-ish in the UKCS. About half of them, 43%, have got well integrity issues. There's a lot of potential value there. Globally, we know that 60% of the wells that are over 10 years old have sustained casing pressure. That's what the industry stats are. There's been surveys in the Gulf of Mexico, there's been surveys in the UKCS, they're all about the same. Well abandonment requires the appropriate isolation of potentially porous and permeable formations. When we drill these wells, folk naturally focus in on the money in the reservoir section at the bottom of the well. They rip through the stuff in the overburden, and quite often there are small sands and porous and permeable beds that, if there is improper isolation or cementing, would cause you problems in the future. And those need to be isolated. Distributed optics has a huge benefit in this situation because it's making measurements over the whole well all the time. And you've got control over the well. So you can adjust the annular pressure, inject into or bleed off different annuli in turn to work out what the potential communication paths are in that well. And that's what fibre buys you, is the ability to see the whole well all the time during that well manipulation. And that is absolute gold dust for trying to track down these sorts of issues. So what we are trying to do as a company is to try and open up the market and stimulate interest from the operators to make it easy for service companies to acquire the data and make it easy for people to interpret it and process that whole picture to come up with these unique solutions. So, and that's me holding the baby. So that's slightly under time, which means we've got even more time for pointed questions.
Thank you very much, Mike. Does anybody...
No.
Does anybody have any questions they want to ask?
Thank you. Good afternoon. My name is Juan Tovar, and I attended the same conference on surveillance a couple of weeks ago. And the thing I came out with that most impacted me after, like you, 36 years in the industry, was this EnQuest manager who said that they love it. All the data, they don't love the price, but they love the technology. But they have no idea what to do with these gazillions of data points they're taking. I went home and said, maybe I should go back to uni or study again or something. It wasn't difficult to comprehend. They have a dilemma on deciding whether it was, do we review the data on a daily basis, on a weekly basis, on a monthly basis, he ventured to say. So, with so much of the stuff, and obviously the technology has been there and it's even getting better, what do we do with the interpretation?
Okay, so there's a couple of points there. Firstly, you do have a problem if you've permanently installed that system, because you need a mechanism for alerting you to when a change has occurred. So, I mean, with acoustic data, you're getting terabytes of data every day. I think I must be one of the bigger purchasers of 8 terabyte hard drives from PC World in Aberdeen, because I've got a cupboard full of these things. And it's difficult because those files are so big, they're only of value when you've extracted the kernels of information that you really want from it. And people get scared about that. But again, we've built the software to winnow down terabytes down to megabytes. And so you can take that information and have that little package offshore that allows you, through normal telecom systems, to push that data back to the beach so that a human can look at it and say, yeah, here's what's going on. We haven't got into the alerting system, but I kind of get the view that we do have cupboards full of acoustic data, distributed acoustic data, that are not being used. We've partnered up with the likes of Paradigm, and what we've done is used their data and said, look, let's go in and let's try out different things, and we're starting to tease out different things from the data. And so it's not out with the bounds of possibility that you could go back into historic data, rerun the processing, and come out with subtly different interpretations. You kind of want to think that the main observations are still sound, but the detail may change. So it doesn't worry me that about acquiring large amounts of data at all. So and it shouldn't worry you. Yeah. So it's not rocket science at all. There's this cloak of mystery about the whole thing, and we need to dispel that. We've been in this arms race in the fibre optic community for years, where I've got a bigger, better box that does fancier measurements, and that's not where we're at. If I wanted to provide seismic quality data, then yeah, I have to play it in that high end. That's not where we are for leak detection, abandonment, and flow assurance and well integrity issues. We're at the different end of the spectrum. We can afford to use lesser performing boxes, but are more robust, cheaper, and quicker to use. I mean, that thing, I've hand carried that to the States and used that in the States. It's just normal luggage. All the other stuff, Pelican cases, shipped in containers, it's not good, and delicate as well. I mean, they're really great instruments, but they are delicate, and if you knock it, it can go. Did that answer the question? Okay.
And Jess?
Paul.
Great presentation, by the way, as I expected. So obviously there's a big prize with old wells, and a lot of old wells aren't going to have a lot of surveillance in them. There's not a lot you can do about that other than intervening. Looking ahead at new wells, knowing what you know about permanent installs and the options you have for intervention and kind of how those technologies are going, if you were starting off with a new well, taking into account cost and all the things, and it kind of ties in with his question there about that's permanent installs. What would you say would be the ideal way to go forward with a new well? Go full tilt and put permanent installs or fibre and everything, or put in something a bit less that permanently monitors, like gauges, for example, and then intervene every now and again on a regular basis with, say, fiber.
So, way back in 2000, at the time of the BP Amoco merger, I was sat there quite happily in Prudhoe Bay as the petrophysicist for Prudhoe Bay, and got a phone call saying, "You're now Mr. Intelligent Well Sensors, so off you go to Aberdeen, that's where your paycheck's going to be." And I had to convince assets to run permanent stuff in wells, because that was the project at the time. And we did a study that looked at what's the value of having a sensor down to gauge setting depth or above the production packer versus over the whole reservoir. And because wet connects and multi-trip completions, it just made it a bit of a nightmare and really escalated the costs. And things like fibre optic wet connects were not great, and they're still not great. But it was about a 80-20 split. So 80% of the value was, if I can get it across the reservoir, fantastic, because that's where the money's at. But there's still a big chunk of value in the 20% in the overburden above the production packer. Now, many wells have permanent gauges, where if you're running a gauge anyway, it doesn't matter if it's electronic or optical, stick a fibre in the cable. And then you just got the cost of terminating at the top, and then it's a plug and play. It doesn't have to be permanent. As soon as you go permanent, you've got an expensive surface box that has to be bought, and you've got to tie it into your SCADA system or whatever other system so you can get the data off it. Far better. I mean that the beauty of that thing is, I have in the back of my head an echometer. Many wells in the lower 48, pump jack wells, use echometers. The guy goes along, connects up, shoots a survey. Yep, here's the liquid level. Moves on to the next well. You can do that with this battery-operated, self-contained, plug and play. So, if you had a new well, you could stick fibre in the gauge cable, and you've got the ability to acquire on demand a survey down to gauge setting depth.
So that sounds, I agree, like putting sort of some in, it's almost like a permanently installed intervention. It's like a hybrid between the two, and it's like, you map it all out, you're going to say, it's going to cost me this, and this is the benefit. If I go permanent install, it's going to cost me like way more, and it's not worth doing. So if you sat down in a group of clever people in the industry said, yeah, that's like the optimum, generally speaking, do you think it would be that we should then legislate for that if you're going to be installing a gauge, you should put fibre in, and you have to make a case to not do it? Because at the moment it's like it doesn't happen because everyone's got their choice to do what they want. And then in 5 years' time, we're all sitting here going, oh, you know what, they should have put this in the well. And But if it was legislated for, like, you have to put a minimum level of surveillance in your well, would that not ease things going forward? I
think legislation is maybe too strong a word. You'd like to think that folk would see the benefits of this capability so that they want to do it anyway. But the other thing to say is, even if I can't afford, or the well is such a skinny economics well that it can't afford a gauge, downhole gauge, more and more frequently people are being, the cable manufacturers are being asked to supply fibre in cable. And so that's going to become a common thing. And right now, for the likes of this stuff, slickline-enabled fibre, that's becoming quite common now as well. And so it's probably going to be the case that instead of it being special that you've got fibre-enabled cable and slickline, it becomes the norm. And then the unit cost comes down, the availability it's more readily available, and so it gets just normal part of business.
I guess when I said meant legislate for, I meant more like, say, the Oil and Gas Authority or some body kind of, it's kind of written in like, there's obviously, when you complete a well, you have to do a minimum amount of stuff in terms of the integrity of the well and these kinds of things. Why not take that a little step further and put in surveillance, because at the end of the day that could help integrity. When you come to abandon the well and you don't know anything about it and you find all these horrible problems, it's like, well, if you put in you've got to make sure the well's secure and monitored to a certain level.
Well, I took Glenn's opening address at that surveillance conference as being oil and gas authorities sort of shot across the bows as to, hold on, this is not okay. You have to do something about this. And if it persists, then they will act. Because, I mean, they're the regulatory authority. You know, they're looking after the nation's assets.
Hi, I'm Richard Stark. I am a PhD student at Dundee University, and I'm looking into liability in perpetuity. So I'm particularly interested in abandoned wells, and the fact that there's a responsibility forever to look after them. And is there something here about the surveillance going forward post-abandonment that in terms of maybe not your equipment, but something of that ilk to monitor what's going on with them, because ultimately a number of them, I would suggest, would fail.
Yeah, so it's an interesting question, that, because the way that it's kind of played out just now is, in fact, these guys, Paradigm, they're out on a platform at the moment on a well abandonment exercise, and the operator in question wants to run a fibre survey just to see if, I mean, all the tubing's out, they've just got the casing in there, they've already set a plug halfway down the well. They just want to check for potential flow and fluid movement in the upper part of the well as they start bleeding off annulus pressure. Now, that's a one-off. Yeah, so, oh yeah, we saw it, or no, we didn't see it. However, you could equally argue that, well, if fibre becomes cheap enough and you could buy one of these drums and then just sort of hang it off and leave it there so you could just plug in and play and make a survey, then you could potentially do that. A bit more difficult for an offshore situation where you get to recover the tree, like, so you're chopping everything. So really you are relying on cement and plugs to give you your appropriate isolation, and you only have the one chance to make a measurement for flow behind casing. But it's amazing how many times when you do these surveys that you do see that. You know, there is communication between porous and permeable beds in the overburden. So it is something that is a potential issue moving forward in mature basins, absolutely. And, you know, getting cheap, easy ways of deploying fibre potentially permanently, but then have a plug-and-play capability to monitor. There's probably quite a good market in that, I would have thought. PhD. Any others? 7 minutes, we've got loads of time.
You have shown us a visualization of distributed optical sensing data, but you have also mentioned AI and machine learning.
Yeah.
Where does all these enter the equation?
Where does the AI enter the equation? Okay.
What do you do with AI and machine learning in the context of visualizing data or analyzing data?
Yeah. So there's a couple of things here. Firstly, the artificial intelligence applied to the parameters, the parameterization of what I want to do is one thing, because right now what we're doing is you're shotgun blasting this thing with whatever parameters we want. We generate a whole matrix of parameters, but then it's very quick to cycle through and pick out the ones that are relevant. And so that there could be some intelligence applied to how we go about that part of the exercise. The other part of the exercise is that if I have a leak, or if I have a movement of bubbles of gas and oil, or oil and water, what's the signature of that? That's the other aspect. And right now, we're only in the place of, we have to keep it simple, and so we do not intend right today to have this application performing those types of tasks. It doesn't mean to say that it couldn't be done in the future. What we want to do is to present a person with the data, and the person makes the interpretation. But if this thing takes off, and all of a sudden we're being asked to do this in every well every other week, You just don't have enough people to do that. And so then it forces you down that route. But today, no. Today, I'm kind of happy if I can generate the images and get it all on the same page so that a human can do it. So it's a very much an open system, not a closed system. I don't want any feedback loop or automation in it. I mean, I know that the BP Light guys, they've gone down the route of it's a permanent thing. They'll suck the data from the box. It goes through Palantir's system. They'll do whatever magic they do, sprinkle their secret sauce in it, and then they'll give you the answer. And so the operator ends up with, oh, here is the answer. But they don't see any of the intermediate steps. And so in terms of false positives or false negatives, I kind of think we're still at the infancy, and so we're not used to seeing all the potential permutations and all the different scenarios out there to be able to do that. And so in terms of a learning data set, I don't think we've got enough stuff to learn on just now. But we will do. So if we get 100, 1,000 wells worth of data, then yeah, that's enough meat to start doing that. But right now, humans.
Makes sense, yes. Thank you.
Any other questions? We've got time for maybe one
4
more.
minutes. We can squeeze in another 2 questions. You got a hard question, Di?
No.
Oh. Graham, reliable as ever. Graham,
Of course, Mike. Of
sock
course.
it to me.
I'm not going to give it a hard time. I'm not going to go into any detail. I want to accentuate the fact, one of the facts you raised, though, is that the difference between a baseline and an active line or a faulty acquisition is essential. Because once you've only got one reference point, it's very difficult to say what has happened to that well. You need to have a baseline of some kind before you make a deduction on how it is at the moment.
Yeah.
And I agree with you in that. I think that the more the better. Plug and play or permanent, doesn't matter. As long as you have a method either of storing it or have a policy of disregard or discard, let's put it that way. Yes, it is big. Yes, it does surprise a lot of people, but I think that the power of it is far in excess of what it's used for at the moment.
Oh.
The yes/no answers or the yes, you've got a leak. It's the potential is much bigger than that.
I often use the kiddies spot the difference thing, you know, where you get 2 images and there's subtle changes in the images. I've used that in the past for a pulse nuclear cased hole, but it works for this equally as well, where you say, okay, here's these 2 images, and you flip quickly between the 2, and you can spot immediately really, really small differences. And that's kind of where I'm at with this. If I've got a baseline and I know everything's normal and it's behaving itself, and then something's changed, to see a subtle difference, you have to have a proper baseline. Otherwise, you're struggling. And so, yeah, baselines I'm always keen on. And then permanent, I'm keen on as well. But it's the expense and also the handling of the stuff. So that's why periodic I'm okay with.
Yeah, the other question which you kind of raised from the cradle to the grave illustration is that the value to be had from permanent surveillance is throughout the well.
Yeah.
Different applications, different values, but the cumulative value of a permanent installation will far exceed the cost of installation.
So, and again, with my old petrophysics hat in my head, Prudhoe Bay, the very first wells in Prudhoe Bay, you had a density neutron gamma sonic resistivity log. And the very recent wells that are drilled, you got a density neutron gamma ray sonic log. And when we rebuild the models, the first wells are equally as valuable in building that model as the last well. And so, you know, and if you had a meter for every time somebody looked at the gamma ray, the resistivity, the sonic from the very first well, and you charge $1 a time, you'd make a fortune. You know, so data, as long as you know its heritage, the metadata that comes along with it, if you knew that, then it's always of value. And so I've never, ever regretted spending money on data. 27-second question? Otherwise, Sarah's going to get really cheaped
That's
up.
that image that you show is what it comes on your device?
No. So this is just purely an acquisition box, and so what we've you can see the image on the box, but you don't get that image. That image is from the software, so you kind of pull the data file in the software, and then it renders this whole thing. But
Okay.
that is just here's the temperature bit. Yeah.
Okay, that's us now. We're
Is
out
that
of
it?
time. That's it.
That was far too
I'm sure you agree that it was quite interesting, an engaging session. If you have any more questions and you want to speak to Mike, he'll be here for, as long as long as you would like. I would ask you though, if you could please take your conversations up back to the reception area, as we've got to clear out this room for something else later. I'll just bring your attention quickly to the screens at the back. They've got the forthcoming programme of Tech20 talks up on them. So if there's anything you think is interesting, then please go and register on Eventbrite, and we'd love to see you here again. Thank you very much for coming.